Good morning everyone. I, Professor Arvind Mudjedha from Department of Mechanical Engineering, welcome you all for the subject Design of Machine Elements 1. Here in this video, we are going to study about the classification of engineering materials and its mechanical properties. So, engineering materials are mainly classified into two types. One is metals and one more is non-metals. First we look into the metals. The metals are mainly classified as ferrous and non-ferrous materials. So in the ferrous materials, it mainly contains of iron, so it is called as ferrous, whereas in the non-ferrous materials, there is no content of iron. The ferrous material is classified as wrought iron, carbon steel, alloy steel and cast iron. Whereas non-ferrous materials we have aluminum, copper, lead, silver, tin, zinc and etc. So these are the classification of metals. Next we look into the non-metals. The non-metals are mainly classified as polymers and ceramics. The polymers are again classified into two types. One is thermosetting polymers, which is popularly known as plastics, and one is thermoplastic materials. In the thermosetting polymers, we have phenol formaldehyde, that is bakelite, and polyester, and next epoxy resins. In the thermoplastic we have PVC, polythene, acrylic and resins. Next we have ceramics. In the ceramics we have refractories, abrasives, glass, cement, concrete. After this broad classification of engineering materials, next we look into the mechanical properties of the materials. The important mechanical properties of materials are elasticity, plasticity, ductility, brittleness, malleability, toughness, hardness, strength, stiffness, resilience and creep. First we'll start with the properties strength. Strength is defined as the ability of the material to resist the external forces causing various types of stresses without breaking or rupture. Or in simple words, we can say it is the ability of the material to resist load without failure. Based on type of stresses induced by external loads, strength is expressed as tensile strength, compressive strength or shear strength. First, we'll look into the tensile strength of the material. Here in the figure you can see that a component is subjected to two equal and opposite forces. So here the tensile strength is defined as the ability of the material to resist a stretching load without the fracture. So this is called as the tensile strength of the material. Next we have compressive strength of the material. So for the compressive strength, you please refer this figure where you can see the component is subjected to two equal forces which are acting towards each other. So this is the ability of the material to resist the compressive or the squeezing without fracture is called as a compressive strength. For the shear strength of the material, here you can refer this figure where the material or the component is subjected to the transverse load. So shear strength is nothing but its ability of the material to resist the shear load and tending to that shear load is nothing but the loads are tending to separate or cut the material. The ability of the material to resist such type of load is called as the shear strength of the material. In simple word, we can say that the ability of the material to resist the transverse load is known as the shear strength. Next we have stiffness of the material. The stiffness of the material is the ability of the material to resist the deformation or deflection under the load. Within the elastic limit of the material, stiffness is measured by the modulus of elasticity. When the material is more stiff, it can sustain the deformation, and when the material is less stiffness, the material will undergo easily under the deformation. The next property is the elasticity. Elasticity is defined as the ability of the material to regain its original shape and size after the deformation when the external forces are removed. Steel is perfectly elastic within a certain elastic limit. Next we have plasticity. Plasticity is defined as the ability of the material to retain the deformation produced under the load on a permanent basis. The property of the material is necessary for forging, stamping, images on coins and ornamental work. So in this plasticity we have to understand that whatever deformation of the material happens, that will remain permanently even after the removal of the load. Such a property is called as the plasticity. The next property of the material is the ductility. It is the ability of a material to be deformed plastically without rupture under the tensile load. Due to this property, material can be drawn into fine thin wires without fracture. A ductile material must be strong and plastic. The ductility is usually measured in terms of percentage elongation or percentage reduction in cross-sectional area of the test specimen. The property of ductility is utilized in wire drawing. Mild steel, aluminum, copper, tin and lead are some good examples of the ductile materials. Next we have malleability. It is the ability of a material to be deformed plastically without rupture under compressive load. Due to this property, metals are hammered and rolled into thin sheets. So that is nothing but because of malleability property, the materials can be drawn into thin sheets. So this is also one of the important property of the material. Next we have toughness. It is defined as the ability of the material to absorb energy up to fracture during the plastic deformation. Toughness of a metal offers the resistance to breaking when force is applied. Toughness is measured by a quantity called modulus of toughness, which is the energy required per unit volume of the material to cause rupture under the action of gradually increasing tensile load. Next we have brittleness. Brittleness is the property of a material opposite to that of ductility, that is lack of ductility. It is the property of a material which shows negligible plastic deformation before fracture takes place. Examples of brittle materials are cast iron, high carbon steel, concrete, stone, glass, ceramic materials, etc. Glass is an ideal brittle material in which stress-strain curve in tension is essentially a straight line. So we can say brittleness is the property of sudden fracture without any visible permanent deformation in the material. Next we have hardness. It is defined as the ability of a material to resist scratching or indentation by another hard body. Hardness is directly related to the strength. Hardness of the material depends upon the resistance to plastic deformation. Therefore, as the hardness increases, the strength also increases. Tests on hardness may be classified into scratch test and indentation test. Next we have creep. The slow and progressive deformation of a material with time at a constant stress is called creep. Whenever a member or part of a machine subjected to a constant stress at high temperature for a longer period of time, it will undergo a slow and permanent deformation, which is called as a creep. This property is considered in designing IC engines, boilers and turbines. Next we have fatigue. Failure of material under repeated or reversal stresses is called fatigue. Machine parts are frequently subjected to varying stresses and it is important to know the strength of material in such conditions. The maximum stress at which the material will operate indefinitely without failure is known as endurance limit or fatigue. So these are the important properties of engineering materials. So these properties we call it as the mechanical properties of the materials, and these are the quite important properties. The next one is resilience. It is a property of material to absorb energy and to resist shock and impact loads. It is measured by the amount of energy absorbed per unit volume within the elastic limit. Resilience is usually represented by the area under the strain curve from the origin to the elastic limit point. Next we have machinability. The ease with which a given material may be worked or shaped with a cutting tool is called as a machinability. Machinability depends on chemical composition, structure and mechanical properties. With the good machinability property of the material can be given a complex shapes using the cutting tools. So it is very important to have good machinability property for the material to bring into the required shape. Next we have weldability. It is the ability of the material to be joined by welding. Weldability depends on chemical composition, physical properties, and heat treatment to which they are subjected. Hence, if the material is having good weldability property, the material can be easily joined and the strength of joining will also be good. So it is very important to have a good weldability property for the material. So these are the mechanical properties of the materials which we have discussed. Next, we are going to discuss about the manufacturing methods. As we know that in the design process, the production is the last step, so the designer must also know the different manufacturing methods. Here, the manufacturing methods are classified as casting, forging, forming, machining, joining, and others. So in the casting, we have sand casting, permanent mold casting, investment casting, die casting, and centrifugal casting. So using these casting methods, the suitable products will be manufactured. Next we have forging. Under this we have smith forging and die forging. Next we have forming. The workpiece is reshaped without adding or removing the material and its mass remains unchanged. So that is the property of this forming manufacturing method. Here in the forming we have hot working and cold working such as rolling, extrusion, drawing and stamping, etc. Next we have machining. It is defined as the process of removing material from a workpiece using power-driven machine tools to shape it into an required shape. In this machining process, we have different types of machines. One is turning, drilling, milling, shaping, planing, broaching, shearing, etc. Next, we have gear cutting, thread cutting, grinding, and finishing. So these are the different types of machining processes. Next we have joining. Joining is the process of joining the two metals using different methods. So here we have first one as arc welding, resistance welding, forge welding, gas welding, thermit welding, soldering and brazing, electron beam and laser welding, and using adhesives. So these are the different ways of joining the materials. Apart from these manufacturing methods, we have powder metallurgy and non-traditional machining. So these are the different ways of manufacturing methods. So in this video, we have come across the classification of engineering materials, different mechanical properties of the materials, and manufacturing methods. In the next video, we are going to see about codes and standards, what is the importance of this, and what is standardization in the machine design. Thank you.